Welcome to the Podkey summary of Build Next Generation Experiences with visionOS 27 from WWDC 2026. This round of Vision Pro news is really about one thing. Apple is trying to make spatial computing feel less like a demo and more like a full creative platform. The big pieces are more raw power from the M5 chip, easier ways to build and stream experiences, and a bunch of rendering tools that make virtual objects behave more like they belong in the room with you. And then around the edges, there are upgrades for web apps, object tracking, accessories, and immersive video that make the whole ecosystem look a lot more serious. At the center of it is the new M5 chip in Vision Pro, and Apple is framing it as desktop-class compute inside the headset. That matters because Vision Pro is pushing over 4K pixels per eye, which is a lot of visual real estate to keep sharp, responsive, and believable. The pitch here is that developers can render complex 3D scenes in real time with a level of fidelity that used to be the territory of high-end PCs. So the displays aren't just impressive on paper. The chip is what makes those displays usable for rich spatial apps, instead of just very expensive screens strapped to your face. visionOS still gives developers two broad ways to place apps in your world, and it helps to understand the difference. Shared space is the more familiar mode. Apps show up as windows or 3D volumes and can live alongside other apps, which makes it better for multitasking and lighter touch experiences. Immersive space is the all-in option. It runs exclusively and can take over your field of view. Within that, Apple offers three immersion styles: mixed, where virtual objects stay anchored to real-world surfaces; progressive, where the user can dial immersion up or down; and full, where you're in a completely virtual environment. That spectrum is useful because not every spatial app wants to whisk you away to another universe. Sometimes you just want a digital object to sit convincingly on your table and mind its business. Apple is also trying to lower the barrier for developers with three different development paths. The first is the easiest. Bring over an existing iPhone or iPad app by checking a box in App Store Connect or recompiling with a visionOS deployment target. In some cases, that means very little code change. The second path is for native spatial apps. That includes SwiftUI, RealityKit, Reality Composer Pro, and custom engines through compositor services, with Unity, Unreal, and Godot plugins in the mix too. The third path is maybe the most practical for a lot of creators. Mac and PC workflows can now extend or stream into Vision Pro through Spatial Preview on the Mac side and foveated streaming for PC or cloud content. In plain English, Apple isn't asking everyone to start from scratch. It's trying to bridge the old desktop pipeline into a spatial one. A lot of the most interesting updates are in RealityKit, where Apple is making virtual scenes react more naturally to the physical room. RealityKit 27 adds a physical space lighting system that blends virtual light with the real environment. So something like a planetarium projector can cast light that conforms to actual surfaces around you. There's also a Projective Textures API, which lets developers project textures from spotlights for effects like stained glass patterns or underwater caustics. This is the kind of detail that sounds niche until you see it. Lighting is one of those things your brain notices instantly when it's wrong. RealityKit also now has real-time cloth simulation, with fabrics that drape, fold, and react to motion with believable weight and inertia. Apple showed it on a mannequin wearing a flowing dress. But the same system works on environmental objects too, like a bed cover moving naturally in a scene. That's a sign that soft body physics are becoming practical at interactive frame rates on Vision Pro, which is a pretty big step for realism. Then there's Gaussian splatting, which lets scanned objects come into RealityKit as dense point clouds built from continuous Gaussian kernels. The useful part is the workflow. It preserves fine detail, like the texture of soil on a potted plant, and it cuts down on manual remodeling for objects that are annoying to recreate by hand. And for the early-stage creative messiness that every project goes through, Reality Composer Pro now has an AI assistant that can generate 3D models and textures from natural language prompts. Apple's example was quickly dropping in things like dried fruit or candles, which is less about final production art and more about getting a scene blocked out fast before the polished assets arrive. For experiences that are too heavy to run entirely on-device, Apple's foveated streaming story is getting much stronger. The foveated streaming framework can stream OpenXR content from a PC or the cloud, and with NVIDIA Cloud XR, it compresses the image more aggressively in your peripheral vision, while keeping the center sharper where your eyes are focused. That dynamic foveated compression keeps bandwidth low enough for Wi-Fi-only streaming, which is how Apple can talk about flight sims and racing setups without dragging a cable across your living room. It's one of those behind-the-scenes tricks that makes a futuristic feature sound oddly practical. Apple is also improving precision tools around object tracking. visionOS 27 adds high frame rate object tracking updates and metric space pose data, which is the kind of thing that matters when use cases get serious, like surgical navigation where millimeters count. Create ML now has an extended training mode for handheld objects, and the same model can be reused on iOS, so developers can carry that AR work across Apple platforms instead of rebuilding it. On the hardware side, Apple has defined a new category called spatial accessories. These devices use visible LEDs, an IMU, and Bluetooth to get low-latency 6 degrees of freedom tracking and haptic feedback in Vision Pro. Reference kits from DFRobot and MicroE are coming later this year, and the examples are kind of charmingly practical. A 3D printed flashlight or a steering wheel mount turned into a track controller. Apple is still pushing hard on immersive video too, and the specs are massive. Apple Immersive Video captures stereoscopic 180-degree footage at 90 frames per second, with visual acuity above 100 megapixels per frame, which adds up to more than 10 billion pixels every second. To make that workable, the Immersive Media Support Framework now includes camera override commands, an immersive preview renderer for real-time Mac to Vision Pro preview, and static fovation techniques to help these giant streams travel over normal internet connections. Meanwhile, Safari in visionOS 27 is getting more spatial too. Windows can resize into wider aspect ratios that curve around your field of view, which makes better use of that giant floating canvas. And web environments are now on by default, so websites can render custom background environments and feel a lot closer to native immersive apps. Taken together, this feels like Apple moving from showing what spatial computing can look like to smoothing out how it actually gets built. More power, better realism, easier pipelines, smarter streaming. It's a very developer-heavy update, but that's usually how a platform starts feeling more real for everyone else. This episode was generated by Podkey. Create your own at podkey.fm. Podkey.